So here's problem 4.1, or from section 4.1, problem number 23. And we want to, in this problem, find extreme values of the function and where they occur. All right? Now, we're not given a closed interval, so we're not guaranteed a local maximum, an absolute maximum or minimum. We know that there's no guarantees here. But what we'll do instead is, let's take a look at the derivative and see if we get any ideas of what's going on. All right? So let's take the derivative of both sides, and I get dy dx is equal to 1/2 x squared minus 1 to the negative 1/2 times 2x, which is equal to x over the square root of x squared minus 1. So far, so good?
Yeah.
Okay, great. Now, I also want to talk about where the domain of this function is before I get started.
Okay.
Are there any values that don't make sense for this expression?
0,
0 doesn't make sense. Any other ones?
1,
Exactly 1?
1 and negative 1.
1 and negative 1? Any other ones? Negative 1/2? Positive 1/2. How about we do this? How about we say, hey, you know what? This expression needs to be greater than or equal to 0 for this function to make sense. Is that right?
Right, because if it was like 1/2.
Okay. Now, this is equal to x minus 1 times x plus 1. Is that right?
Right.
When is this product greater than 0? When either of them are positive, when either of these two factors are positive, or when both of them are negative. When are they both positive? They're both positive when this is greater than 1. When are they both negative? When both of these are less than negative 1.
Okay.
This domain ends up being the interval from negative infinity to negative 1, including 1, negative 1, and 1 to infinity. There are the locations where that function is even defined.
Okay.
All right? Now, let's look at the derivative for a second. Let's talk about critical points. Those points which make the derivative either 0 or make the derivative undefined. Now, negative 1 is a valid location in the domain, but negative 1 is going to create an undefined derivative. So I'm going to say that x equals negative 1 is a location of a critical point.
Right.
Positive 1 is in the domain, but positive 1 will make the derivative undefined. So I'm going to say another location of a critical point is at x equal 1. Lastly, if I look at this, the value 0 would make the derivative 0, but 0 is not in the domain. So I'm not going to worry about 0. It's not even in the domain.
Okay.
All right. So what do we have? For dy dx, we've got a number line. I'm not worried about what goes on in here because the function's not defined in there. All right? The derivative is undefined at negative 1. Can I ask the question, what about all the rest of this area in here?
It's defined.
It's defined. Not only is it defined, but it's a single sign. It's either all positive or all negative. Because the critical points are the places where the derivative can change sign. If I put any number in this particular portion of the number line into here, I get dy dx being negative. If I take any value from this part of the interval and I put it in my derivative, I get dy dx being positive. So if I were to think about what does this function look like, I would say this function decreases, goes through an interval of being undefined, and then it increases. At the critical point where x is equal to -1, it's on the long tail end of a decreasing function. Let me use the right notation. The value of y when x is equal to -1 is equal to the square root of -1 squared minus 1, which is equal to the square root of 1 minus 1, which is equal to 0. Okay, so the point -1 comma 0 is at the long tail end of a decreasing function. I declare this to be a local min. Let's find out the value of y when x is positive 1. I get the square root of 1 squared minus 1, which is equal to square root of 1 minus 1, which is 0. The point 1, 0 is at the start of a situation where the function then starts to increase. I declare this to be also a local min. Because I'm thinking about the derivatives and how the derivatives start, they're undefined, and then they become positive. All right?
Okay.
Now, is there any possibility that there's some value lower than 0 coming out of this function?
No.
The smallest value a square root can ever produce in the real numbers is 0. These are both local maxes, local mins and absolute mins simultaneously. Now, we weren't guaranteed that we'd even have a local max or local min.
Right.
Or an absolute maximum, because we're not on a closed interval and it's not continuous, but they definitely exist here. Okay, now I didn't ever graph the function. This, I don't even know whether this is what the function looks like. It probably looks like this. Okay, but I used what I knew about the derivative to say decreasing, 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 undefined. Undefined, increasing, 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 increasing.
Okay.
All right, and that's how I, without using the calculator, I can get at these problems.
So there's just no local maximum.
Then there's no local maximum. Right. But I wasn't guaranteed a local maximum.
Right.
Right? Should I kill the recording here?